While you were sleeping last night, an AI was planning a route across another planet, not in a simulation, not in a test environment. On actual Mars, NASA just used Anthropic's Claude to chart the navigation path for the Perseverance rover, and the rover drove it over 800 feet across Martian terrain, following waypoints generated entirely by artificial intelligence. This is the first time in human history that AI has independently planned a route on another world. But here's where it gets even more interesting. At the same time, one AI is literally driving on Mars. One of the most influential minds in artificial intelligence is saying the entire approach behind these systems might be fundamentally wrong. Yann, LeCun, a Turing Award winner, just left Meta to build something completely different. Let's break down what's happening. On December 8th and 10th, 2025, NASA's Perseverance rover completed 2 drives on Mars that were planned entirely by artificial intelligence. This wasn't a proof of concept or a laboratory demonstration. This was the real thing. The drives covered 689 feet and 807 feet respectively, guided by waypoints generated by Anthropic's Claude AI models. Here's how it worked. Engineers at NASA's Jet Propulsion Laboratory fed Claude high-resolution orbital imagery from the Mars Reconnaissance Orbiter, along with terrain slope data and digital elevation models. The AI analyzed this data, the same data human planners use, and identified critical terrain features: bedrock, outcrops, hazardous boulder fields, sand ripples. Then it generated a continuous path with waypoints that the rover could safely navigate. Before any commands went to Mars, JPL ran everything through their digital twin, a virtual replica of the rover verifying over 500,000 telemetry variables. Safety remained paramount, but the results were remarkable. NASA estimates this AI-assisted approach cuts route planning time in half. That means more drives, more scientific data, and ultimately more discoveries about Mars. Vandy Verma, a space roboticist at JPL, called out the fundamental elements: perception, localization, and planning. Generative AI is showing promise across all 3. This is a milestone that transcends space exploration. For years, the conversation around AI has centered on code generation, chatbots, and content creation. Useful applications, but not exactly mission-critical. NASA just changed that calculus entirely. They trusted an AI system with route planning for a $2.5 billion rover on another planet. The implications ripple outward. If AI can handle the complex reasoning required to navigate unpredictable Martian terrain, where a single mistake could end a mission, what else becomes possible? Autonomous scientific research, complex logistics planning, real-time decision-making in environments where human oversight isn't feasible. This wasn't just Claude passing a benchmark or scoring well on a test. This was operational deployment in one of the most demanding contexts imaginable. And it worked. NASA's confidence here signals something significant. AI reasoning has crossed a threshold from experimental to reliable enough for the highest stakes. Watch for expanded autonomy. NASA has proven the concept works. The next step is deeper integration. As Perseverance continues its mission, expect AI to handle increasingly complex planning tasks. The real question is how quickly this expands beyond Mars. Lunar missions, asteroid exploration, and eventually crewed missions to Mars all face similar planning challenges. If AI can cut planning time in half while maintaining safety, it becomes an essential tool for ambitious space exploration. Other space agencies and private companies will be watching closely. So NASA is betting on large language models to push the boundaries of space exploration. But not everyone believes that's the right path forward. In fact, one of the most respected voices in AI research is making a very different bet, and putting his career on the line to prove it. He thinks the entire industry might be building on the wrong foundation. Yann, LeCun just left Meta. That alone is significant. He was their chief AI scientist, and one of the most influential researchers in the field. A Turing Award winner. One of the founding fathers of deep learning. But he didn't leave to retire. He left because he believes the entire AI industry is headed in the wrong direction. LeCun has launched a new venture called Advanced Machine Intelligence Labs, and he's also joined Logical Intelligence, a San Francisco startup, as founding chair of their technical research board. His message is blunt: the industry is, quote, completely LLM-pilled. Large language models, The architecture behind Claude, GPT-4 and Gemini will never achieve human-level intelligence. A completely different approach is needed. Logical intelligence is building what they call energy-based reasoning models. Instead of predicting the most probable next token, which is how LLMs work, these systems learn by recognizing and correcting their own mistakes. They're framing reasoning as an optimization problem rather than a prediction problem. Their first model, Kona 1.0, is entering pilot programs in energy manufacturing and semiconductors. Meanwhile, LeCun's other venture focuses on world models trained on video and spatial data, systems that understand physical reality, not just text patterns. Consider the stakes. OpenAI, Anthropic, Google, Meta before LeCun's departure. Collectively, these organizations are pouring hundreds of billions of dollars into scaling language models. The operating assumption is that bigger models, more data, and more compute will eventually produce artificial general intelligence. LeCun is saying that's a dead end. Not that it won't produce useful tools, clearly it has, but that it will never produce genuine understanding or human-level intelligence. If he's right, the current AI gold rush is building toward a ceiling, not a breakthrough. Now, LeCun has been wrong before. And the LLM approach keeps surprising skeptics. But this isn't a random contrarian. This is someone who helped create the foundations that modern AI stands on. When he says the entire paradigm might be misguided, it deserves serious consideration. At minimum, it suggests the race to AGI might not be as straightforward as the current funding frenzy implies. Keep an eye on Logical Intelligence's pilot programs and any technical papers they publish. The proof will be in performance. Can energy-based reasoning models solve problems that LLMs struggle with? Can world models demonstrate genuine understanding rather than sophisticated pattern matching? The timeline matters too. If LLM scaling continues to deliver impressive results, the alternative approaches might remain academic curiosities. But if progress plateaus, if we hit diminishing returns despite massive investment, LeCun's thesis could reshape the entire industry. An AI just drove on Mars. And one of the people who made AI possible says the whole approach might be wrong. That tension between what's working right now and what might be fundamentally limited defines this moment in technology. The question isn't just whether AI will transform everything. It's which AI. And we might not know the answer for years. If you want to stay informed as this unfolds, subscribe. New developments drop daily. See you in the next one.